Okay, welcome back. So let's start doing some problems. Okay, so we're going to start doing some problems. So the first problem we have, let me look here, is find the volume of the solid obtained by rotating the region. So almost all the questions in this section are going to be of this type, okay? And then it's just going to be what region and around what axis. So y equals 1, region bounded by y equals 1 minus x squared, y equals 0, about the x-axis. Okay? So, again, one of the first things I'm going to tell you is we should always be drawing these pictures. Okay, so let's draw a picture of the region here. Y equals 1 minus x squared, so that's like so. Okay, parabola facing down, up 1. It's got zeros at 1 and negative 1. And then we're taking this region. Okay, now we're going to rotate it about the x-axis. So that means we're going to rotate it this way. Okay. Okay, so I'm going to set up these problems using both circular disk method and cylindrical shell method, if possible. Okay, so let's start with the circular shell method, which is the picture that I've sort of done here. Okay, so now in this case, our integral, the x-axis is this way, right? So our integral should be an integral in x. All right, so we're going to take the integral from negative 1 to 1, negative 1 to 1, pi, the radius. What's the radius here? The radius is given by this y equals 1 minus x squared. But remember, we square the radius. Okay, so pi r squared dx. Okay, pretty standard integral to do. I'm not going to go through doing that. I think we can all do that. But let's also look, what if we wanted to solve this via cylindrical disk? Okay, might be a little harder. This was actually intended to be done with cylindrical shell or circular shell, but let's go ahead and see what we could do with cylindrical disks. So draw the picture again. Draw y equals 1 minus x squared again. Sure, that looks like it. Actually probably looks a little better than the other one. Okay, so now what I'm going to do is I'm going to take, and if I want to do this with cylindrical disk, remember we're doing, the rotation is about the x-axis, so our integral should be perpendicular, should be in y. And we're going to take this distance times this distance. Okay, so let me draw a typical this should have been a circular disk. And this should have been cylindrical shell. I always screw those names up. Okay, so our typical shell is going to be like so. Okay, so what is our integral going to be? Well, we're going to integrate from 0 to 1 because we're integrating in y. Now, let me do the, 2 pi, okay, because there's a 2 pi for the surface area of a cylinder. Let me write r of y, h of y. And let's figure out what those are. Okay, now r of y is actually pretty easy. R of y is just y. Okay, that's just this distance. Now, let's look at this. So here we have, this is y equals 1 minus x squared. So we could solve this as saying x equals y minus 1 plus or minus the square root, right? Okay, so what's going on here? This is the positive square root of y minus 1. This is the negative square root of y minus 1. Okay. Let me move that over here. Move that over here. So we're going to have the integral 0, 1, 2 pi y times our h of y. That's going to be 2 times the square root of y minus 1. Okay, so both of these integrals are actually not super hard to do. Okay, so, you can try both of them and see that you do get the same answer. You should, okay, if we've done everything correctly. I don't think it's too difficult. One thing, when I'm doing these, I should probably be a little more clear. I do want to see you write down what r of y is and what h of y is, just because it's going to be easier for us to grade, okay? Here it should be pretty clear what r of x is in the circular disk method. Okay. All right. Let's do another one. Set up another one. Okay. So I'm going to just copy this again. Because like I said, all these problems tend to be the same format. Okay. Let's make things a little bit smaller. Or at least move them up. Yeah, let's make it a little smaller. Okay, so we're going to find the volume of the region, volume of the solid obtained by rotating the region, bounded by y equals 1/4 x squared, x equals 2, y equals 0, about the y-axis. Okay, again, we're going to draw the picture. Now, y equals 1/4 x squared. That's, again, a parabola, but this one goes through the origin. So this is a Hopefully pretty simple one. Okay, x equals 2. X equals 2 is over here. And y equals 0, let's make that a little thicker. That's here. So this is the region that we're bounded by. Now, we're going to rotate it about the y-axis. So we're going to rotate it about the y-axis here. Okay, so that means if we want to do this with circular disk method, okay, circular disk method, that means, so what we're going to do is actually, this one is a little bit tricky, which is why I wanted to do it, is we're actually taking sort of what's called an annulus. An annulus is one circle inside of another. Okay, so there, when we do that, we're going to have an inner radius and an outer radius. Let's call it Ri and Ro. Okay, and if you have a annulus, I have shape completion, I may as well use it. Sure, that'll work. That'll be as close to a circle as I can get. Make it smaller. Okay, we want to find, let's say, this region. Okay, the area is going to be pi times r0 squared minus pi times ri squared. I should call it ro and ri. Okay, so it's the area of the whole thing minus the area of the inside. Okay. Okay, so let's go ahead and for this one, we're going to indicate what is the inner radius and what is the outer radius. So this is our center. Our center is x equals 0. I like doing that too. Okay, I like sort of indicating what is our center of each circle. Okay, our inner radius. Our inner radius, well, if this is given by y equals 1/4 x squared, since our integral is going to have to be in y, we're going to need to write that as x as a function of y. So that means x is going to be the square root of 4y, or 2 square roots of y. Okay, so that's going to be our inner radius. Our outer radius. Well, our outer radius is going to be from there to there. That's the line x equals 2. Okay, so in order to do this one with circular disks, okay, in order to do this with circular disks, let me actually make a little more space for myself. I missed one thing there, but oh well. Okay, so the circular disks is going to be the integral from 0. This point, okay, remember it's given by x equals 2. So if x equals 2, what's the y coordinate? The y coordinate is going to be 1. Okay, I'm just plugging x equals 2 here, or x equals 2 in there to get y equals 1. Okay, pi times outer radius is 2. Remember, it's squared. Minus inner radius is 4y. Well, it's 2 root y, but when you square it, it's 4y dy. Okay? Now, I'll be honest, doing the cylindrical shell, this one's a lot easier because you're just doing this way, right? So this should also equal using the cylindrical shell method, the integral from 0 to 2. Okay, so now remember, when you do cylindrical shell, you're doing that perpendicular to the axis of rotation, right? So, or the axis, right. So the axis of rotation moves along y, so you're going to integrate along x. Okay, 2 pi x, and then h of x is 1/4 x squared dx. Okay, so those should be the same thing. Okay, all right, we'll see you in the next video.